Oily water separator. See the operation of an oily water separator with a 15 ppm monitor. The separation of oil water in the separator takes place in two stages. In the first stage, the separation is by gravity, whereas in the second stage, the separation is by coalescing filters. Bilge pump delivers clean seawater to the first stage of the separator through the inlet valve. The vent is kept open till all the air is removed from the separator and water issues out. Oily water is delivered to the separator. As it enters through the inlet valve, oil separates by gravity and collects at the top of the separator. The remaining oil sticks to the baffle plates as the water passes to the second stage. Oil droplets from the plates tend to travel upwards to the oil collection space. Oil from the top of the chamber is automatically drained to the oil tank, where the level reaches the bottom of the sensor as shown. The oil drain valve from the top of the first stage separator is a diaphragm-controlled piston valve. Control air is supplied to the diaphragm through a solenoid-operated pilot valve. The capacitance probe senses oil quantity in the collection space and energizes the solenoid through the control switch. Water passes downwards from the first to the second stage coalescer through a central pipe. The filter in the right chamber removes solids and some oil. Coalescing filters in the left chamber take out the remainder of the oil in the form of small droplets, which coalesce to form larger drops. These rise to the oil collecting space. Oil content of the final discharge is below 15 ppm. In case the discharge of water after the second stage is more than 15 ppm, the monitor senses this and gives an audible and visual alarm in the engine room. At the same time, the monitor sends a signal to the three-way valve on the overboard discharge line, which closes the overboard and opens to the bilge tank. The sensor reverts to normal operation once the oil content drops below 15 ppm. The test cocks can be used to ascertain the levels of oil and water manually. A spring-loaded valve is usually fitted on both discharges. However, it is essential that a relief valve be provided on the shell or incoming mixture line to prevent overpressure and accidental discharge to a confined space or prevent overboard under all working conditions. Such a relief valve should be preferably led back to the suction side of the supply pump or to an overflow tank. The usual working pressure for the separator is in the region of 2 bar, that is, the pressure at which the spring-loaded water discharge valve is set. The relief valve is set about 2.5 bar approximately.